Welcome to Maroff Channel. Many laborers are fighting hard against the violent ocean currents to complete the construction of an underwater bridge pier. Are you able to spot a mistake made by the chief construction engineer here? This mistake will result in a catastrophe. Welcome to civil engineering's most challenging task, underwater construction. Even though we call it underwater construction, today's engineers avoid water altogether when building an underwater structure. To remove water from your construction area, you must first build a temporary dam called a coffer dam. Working directly under the water is far from a practical method. The next question that arises is how to build the coffer dam under the water. The first step is to erect these guide piles with the help of a pile-driving hammer machine. The guide piles provide guidance for the construction of the coffer dam. Then workers will drive many sheet piles into the soil with the help of the same machine. These sheet piles have interlocking connections at both ends of the section. Such a clever interlocking mechanism means that water leakage will be minimal. The sheet piles are driven under the ocean bed till they reach the bedrock. The order of piling is from the corner to the center. The alignment can be maintained this way. Have you noticed anything special about the pile-driving hammer machine? It isn't just pushing the sheet piles down. You can imagine easily what would happen if the sheet piles were pushed into the soil. To penetrate the soil, the machine uses vibration. If you observe carefully, you'll see these tiny but fast vibrations. The specialty of this machine lies in the fact that it consists of two counter-rotating eccentric weights. The purpose of these weights is to induce vibration in a machine. This flat surface-looking ship called a barge is employed to carry machinery and components that are required on the construction site. Now we're ready for the big phase of the construction project, pumping out the water from the coffer dam. However, before doing all this work, the engineers had a major assignment to do. Let's see what this was. Before getting into the water pumping phase, the engineers of the project had to do a detailed geotechnical study of the soil on which the coffer dam was going to be constructed. They selected the land so that it would be able to carry the load of the permanent structure. The most commonly used test for measuring soil strength is an in-situ test called a cone penetration test. You can see how the cone penetration test device is kept on the ocean bed. The conical tip of the device penetrates in the soil, and sensors send back friction and soil resistance values. They will continue the penetration till the point they reach the bedrock. You can see the sudden jump in the resistance value once the bedrock is reached. With the help of this handy test, the engineers know how deep the sheet piles must be driven. The sheet piles should reach the bedrock. Now let's jump back to the project and begin pumping water out. As the water level lowers, you'll notice water leakage between the sheet piles. This is due to differential pressure of the water. Single-layer sheet piles are failing, so we need to